This program is brought to you by the Ministry of Education and Vocational Training Zanzibar in collaboration with Good Neighbors. The program is funded by KOICA.
For our lovely teachers, the program will help you to prepare a simple lesson for your students so that they will learn with joy and improve their performance as well as competency. Remember, self-assessment is allowed.
Who's that?
It's me, Musa.
Musa. Okay, I'm coming out.
What's wrong, Salma?
I'm pulling the door, but I can't open it.
Push it.
No, you push and I pull.
All right. 1, 2, 3. Push.
Musa,
Yes?
use more force and push the door near the hinges.
Hinges? Do you mean near the bawaba?
Yes, hinges mean bawaba.
Okay. So how do I use more force?
I mean push more.
Okay. When I push more, I use more force. 1, 2, 3. Force.
Thank you. Are you alright?
Yes, I'm fine. How about you?
I'm alright, thank you. Where are you going with the bicycle?
I want to go to the physics tuition, but I have a problem with my bike's front wheel.
I will borrow you my dad's motorcycle toolkit if you know how to fix it.
Not very well, but I will try.
Musa,
Yes?
here it is.
Thank you.
What the topic are you going to study at your tuition today?
The topic today is about force.
Force?
Yes.
That's interesting. I want to come too.
You are welcome.
Thank you.
So let me fix it quickly with this spanner.
Alright, but the spanner alone cannot open the nut.
So what else can I use?
Force?
Force?
Yeah,
Can a force open a nut too?
I think so, but try and see.
Alright. Hold the bike tight if you want a lift.
If the nut open,
Not yet. It's too tight.
then try to push it with more force like when you push the door open.
No. I think now I should use more brain than force.
Brain? Are you serious? Okay, I would like to see that.
Ooh, it's still tight. Salma, I must use more force to open the nut.
Yeah, just like when you used more force to push the door open.
Yes, it's open.
Well done.
Thank you. I noticed something when I was pushing the spanner with more force.
Really?
Yeah,
What did you notice?
I noticed that the force I used turned or made this nut to rotate. Look.
Well, because it turns or rotates the nut, then it is a turning force. What do you think?
A turning force. Yeah, that makes sense. So we can say that when you push an object to turn or rotate, we are applying a turning force.
Apply? Is it like use?
Yeah, quite similar. But apply is to make something work.
Okay. Then we can say that when we push an object to turn or rotate, we are applying a turning force.
Alright. Now try to apply your force to turn or rotate the second nut.
Okay. Give me the spanner. I'm a superwoman.
Here you go.
It's open. Whoo!
Well done, Superwoman.
Whoo! Whoo! Thank you. You know what?
Tell me.
I noticed that when you push an object, there is a special time when the force causes an object to turn or rotate.
Yeah, I know what you mean. And so, we can call it a special time.
Fine. What is the other word for time?
The other word for time is moment.
Yes, moment. So when the force causes an object to turn, this turning effect can be called moment.
Okay. When a force caused an object to turn, this turning effect can be called moment. Why is it called moment?
I think because the turning effect allows an object to turn or rotate about a turning point or pivot.
Wow, that's a good point. It is called moment because the turning effect allows an object to turn or rotate about a turning point or pivot. And a pivot is...
Well, I think a pivot or point must be that central point which an object turns or rotates.
I think you are right. Because I could even feel the force in my hand when the nut was turning or rotating.
Yeah, I felt it too, especially when I applied more force.
Could it be the result of the turning effect of the force due to the weight of the mass?
Yes, it is definitely the reason of the turning effect of the force due to the weight of the mass. Close the nut, then try to open it again.
Yeah. First, I applied a little force. Then, I applied more force. And I felt the turning effect occurring.
Musa,
What's up?
therefore, the turning effect depends on the size of the force.
You are absolutely right that the turning effect depends on the size of the force. Because first, you applied a small size of force, and the turning effect did not occur.
But when I applied a big size of force, then the turning effect occurred.
That's right. And if the turning effect depends on the size of the force, then I think that the moment of force must have a magnitude.
Magnitude? What is that?
Magnitude is a great size of something. In this case, it is a great size of force.
Okay, then it is true that turning effect depends on the size of the force.
That's right. Salma,
Yes?
hold the spanner and try to open the nut.
Okay, I know you want to prove something.
The point which you are holding the spanner tells me that turning effect also depends on the perpendicular distance from the pivot.
Great thinking, Musa. The turning effect also depends on the perpendicular distance from the pivot. What is perpendicular?
Perpendicular is a straight line which makes 9 degrees from the pivot.
Do you mean the perpendicular distance from the bolt to where you are holding the spanner?
Yes, that is a perpendicular distance.
Okay, but Musa,
Yes?
there is also this distance from where I'm holding the spanner to my body. Can this be a line too?
Yes, it can be a line. And we can draw it from where you are holding the spanner to your body, and then call it the line of force. Salma,
Yes?
I have an idea.
Alright, tell me.
Let's call it the line of action of a force.
Line of action of a force?
Yes.
So line of action of a force is a line drawn from the point where a force is applied and through the body which the force is acting.
Yes. A line of action of a force is a line drawn from the point where a force is applied and through the body which the force is acting.
I think these lines of actions causes rotation motion to occur.
You are right, but only when they do not pass through the center of gravity.
So, rotational motion occurs when the line of action does not pass through object's center of gravity.
Yes, but sometimes we push objects and instead of turning or rotating, they go straight.
You are right. I think a translational motion occurs.
Okay, if a translational motion occurs, then the line of action must be passing through the object's center of gravity.
That's right. A translational motion occurs when the line of action passes through the object's center of gravity.
Well, Salma, time has passed, so hold the wheel at the center. I want to apply force and close the nut.
Of course I will, because I want a lift to tuition and back.
Soma, soma mwana soma, uwe mjini. Soma, soma mwana soma, uwe kijijini. Soma, soma mwana soma, ukiwa na mahitaji maalum. Soma, soma mwana soma.
Musa, look at the nut. It's rotating from the right to left, but when I opened, it rotated from left to right.
That's true, and it means there are two rotations. Right to left rotations like arrows of the watch, and left to right rotation.
Right to left rotation like arrows of the watch. Then that is clockwise rotation or motion.
Yeah, if right to left is clockwise rotation or motion, then left to right must be an anti-clockwise rotation or motion.
Clockwise motion and anti-clockwise motion. These are directions, Musa.
Yeah,
So, if a force rotates clockwise and anti-clockwise, then a moment of force must have a direction.
yes, moment of force has direction. Yani mwelekeo. For example, clockwise and anti-clockwise. Look at the nut, Salma.
Yes, it's true that moment of force has direction. Musa,
Yes?
why are you applying force at the almost far end of the spanner, leaving a large space between hand and the turning point?
Because the effect of force and distance determines the magnitude of the turning force, and that is a moment of force.
Alright. So, moment of force about a point is the product of the force and the perpendicular distance of its line of action from the point.
Exactly. And the moment of force is measured in Newton meter.
Okay. Therefore, moment of force is equal to force times perpendicular distance from the pivot.
Yes, moment of force is equal to force times perpendicular distance from the pivot, which means moment of force is equal to F times D.
Musa,
Yes?
imagine I'm applying a force of 5.0 Newton onto a spanner of 15 centimeter long. What is the moment of force?
Alright, let me try to answer.
Okay.
F is equal to 5N. D is equal to 15 centimeter divided by 100 meter is equal to 0.15 meter.
Wait,
Uh-huh.
I don't understand why you divide 15 centimeter by 100.
Do you remember that moment of force is measured in Newton meter?
Yes, I do. So you mean that we must divide 15 centimeter by 100 to change centimeter into meter.
Absolutely. Therefore, moment M is equal to force times distance, which means F times D, which is equal to 5 times 0.15 meter is equal to 0.75 Newton meter.
Can you repeat, please?
Sure. F is equal to 5n. D is equal to 15 centimeter divided by 100 is equal to 0.15 meter. Therefore, moment M is equal to F times D is equal to 5 times 0.15 meter is equal to 0.75 Newton meter.
Wow! Physics is very interesting.
Yeah.
F is equal to 5n. D is equal to 15 centimeter divided by 100 is equal to 0.15 meter. Therefore, moment of force M is equal to F times D is equal to 5 times 0.15 meter is equal to 0.75 Newton meter. Is the bike fixed?
I think it is, but let me try it.
Okay, you try it, and I'm going to get myself ready to go to the tuition.
Salma,
Yes?
the bike is well fixed. Thanks to Superwoman Salma and Engineer Musa.
We are the future engineers.
Sure. Now sit at the back, please.
Okay.
I want to start to apply force on the pedal to make the bicycle wheels rotate.
This is interesting. You are applying the force, and you are really making the wheels rotate in an anti-clockwise motion.
Yeah, it's true. You are so smart. What else is interesting?
The turning effect of a force and the moment of force. What about you?
Well, it is interesting that the turning effect of the force depends on the size of force, but also depends on the perpendicular distance.
Yeah, remember the force has magnitude but also direction.
You are right, Salma. And it is good that you can calculate the moment of force.
Yeah, I think the formula of moment of force is M is equal to F times D and is measured in Newton meter.
Alright, Salma. Here we are. See you after the lesson.
Thank you for the lift, Musa.
Don't mention it.
Dear listener, I hope you are following Musa and Salma's conversation very carefully, right? If so, then I believe you have learned things about the moment of a force. Well, our friend Musa and Salma are now in the tuition. So, let's take a break until the next program. See you.
Happy, 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 happy. Radio class. Happy, 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 happy. Happy, 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 happy. Radio class. Happy, 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 happy. Yeah. You can be a pilot, you can be a doctor, you can be a soldier, you can be a lawyer. If you believe you can.